Hello everyone, welcome back to Makaut Smasher. Today we are diving into an exciting and innovative subject, Adhoc and sensor network, a critical area in the modern wireless communication. This topic forms the backbone of advanced technologies like the IoT, smart cities, and autonomous system. We will explore the basics of the wireless network, mobile ad hoc network, mannet, and sensor network, discussing their architecture, protocol, and challenges. This video will be the overview of the whole subject. Okay, whether you are preparing for exams for the future project, this video will give you a strong foundation. Stay tuned as we simplify the complex topics and demonstrate the real world relevance. So let's unlock the potential of this fascinating network together. Don't forget to like, share and subscribe for the more insightful video. So now let's get started. At first, the overview of the wireless network, the first chapter. Wireless network enable the communication without the physical connection using like the radio waves, like the infrared or satellite communication. They can be classified into two types: infrastructure based network like the Wi-Fi, cellular network, and infrastructure less network such as mobile ad hoc network, mannet. So mannet are the self-organizing network where devices communicate directly without relying on the centralized infrastructure. These networks are dynamic, adapting to node mobility. Sensor network, a type of infrastructure less network, it focuses on monitoring the environment or the systems. They consist of small, resource constrained devices capable of sensing, processing, and transmitting the data. While MANET emphasizes the communication, which is infrastructure based, it emphasizes the communication, the sensor network, prioritize the data collection and energy efficiency. Both share the challenges like the limited energy, scalability, and reliability. So now the architecture. Sensor network architecture is centered around individual sensor node designed to operate efficiently with the limited power and computational resources. A typical sensor node include the sensors, a microcontroller, and communication modules and a power supply. Design constraints resolve around minimizing the energy consumption while also maximizing the data accuracy and network lifespan. Operating systems like the TinyOS are tailored to meet this constraint. Real world examples of sensor node include the Berkeley modes, which integrate the sensing and the communication. Sensor nodes are deployed in environments ranging from the forest to the urban areas. This architecture emphasizes the modularity and adaptability, making them suitable for dynamic and the large scale network. So now the communication protocol. Communication in sensor network begins at the physical layer, where transceiver designs ensure the low power consumption and the signal integrity. At the MAC layer, protocols like the SMAC and wake up radios helps to reduce the energy wastage by managing the communication cycles. Routing protocols play a critical role, offering the energy efficient data transmission method. Popular routing techniques include the flooding, gossiping, and protocols like the leech, which minimize the energy used by ra- rotating the cluster head. We will discuss these topics also in the later videos. Okay. So geographic routing leverages the node positions for efficient data points, data paths also. Additionally, the data centric protocols like the direct diffusion focus on delivering the specific information. These layered protocols optimize the network performance while addressing the unique sensor network challenges. So now the infrastructure establishment. Infrastructure in sensor network involve organizing the nodes for the optimal communication and energy use. Topology control balances the node connectivity and the power efficiency. Network can be flat or hierarchical with clustering enhancing scalability. Time synchronization protocol like TPSN, RBS, it ensures the coordination across the nodes. Localization algorithm helps the nodes to determine their positions. It also essential for tasks like the routing. Techniques like the single hop and multi hop localization adapt to network size and the deployment environment. Establishing the robust infrastructure enhances the network reliability and support the applications like the disaster monitoring, the healthcare, and the precision agriculture. So now the sensor network platform and tools. Platforms for sensor network provide the hardware and software required for the development and deployment. Berkeley modes are the popular sensor nodes offering the customizable solutions for various applications. TinyOS, a lightweight operating system, is often used alongside programming languages like the NESC, simulation tools like the NS2, TOSIM, enable the developers to test the network performance under the different conditions. These platforms address the challenges like the resource constraint and the scalability, empowering the researcher to innovate by integrating these tools. Sensor network can achieve the high efficiency and the adaptability. So that's wrap up our brief overview of the Adhoc and sensor network. Today we explored the fundamental from the wireless network and mannet to the sensor network architecture and communication protocols. The subject is not just theoretical, it holds immense practical significance in the fields like the IoT, healthcare, disaster management. In the upcoming videos, we will dive deeper into each topic, providing the detailed explanation of the and the real world examples. Make sure to subscribe Makaut Smasher so you don't miss out. If you found this video helpful, please give it a thumbs up and share it with your friends. Let's build a community for tech enthusiasts together. Thanks for watching and see you in the next video.